According to a recent article, 32% of drivers have driven drowsy in the past month. Law enforcement officials are planning a survey of 1,000 drivers to determine what proportion are driving drowsy. So we're going to describe the sampling distribution of P hat, the sample proportion of drivers who had driven drowsy. So key information here, 32% of drivers had driven drowsy. They want a survey of 1,000 drivers. So what do we know? We know that P is 0.32 and N is 1,000. So we have to check a couple of conditions to make sure that we have a normal distribution in order to calculate some probabilities. So first condition we want to check for is that either the sample values are independent or the sample size is less than or equal to 5% of the population size. So n, lowercase n, is equal to 0.05 capital N. Let's start with that. So if we look at 1,000, we don't know capital N. Let's look at what 5% of some number would give us 1,000. So let's solve for capital N. So I'm going to divide both sides by 0.05. About 5%. So 1,000 divided by 0.05 would give us 20,000. So what we have here is that the sample size, 1,000, is 5% of 20,000. Right? So there are probably more than 20,000 drivers in a nation. So the condition, right, some space here so I can write it, is verified. I'm going to fill the blank here, so I can't type that. Right, so our condition here is N times P times 1 minus P, nope, wrong condition. Our condition here is that N is less than or equal to 5% of capital N, right, is verified. So that's the first thing we want to check for. Right. The second thing we want to check for, we'll slide this down. Okay. So the second thing we want to check for is that N times P times 1 minus P is greater than or equal to 10. So N times P, so N is 1,000, P is 0.32, and then 1 minus 0.32. I'm going to type that in my calculator here, so 1,000, C 0.32, close parenthesis, open parenthesis, 1 minus 0.32, close parenthesis, enter, we get 217.6, which is greater than 10. So since N times P times 1 minus P equals 217.6, which is greater than or equal to 10, the condition N times P times 1 minus P greater than or equal to 10 is verified. just going to erase this. This doesn't look good. Right? So since n times p equals that value, the condition n times p greater than or equal to 10 is verified, right? So we've verified normality, right? I'm going to just move this down some more here. Right? So since n is less than or equal to 0.05 times capital N, and n times p times 1 minus p is greater than or equal to 10, the sampling distribution of p hat is approximately normal. Now we just need to find the center and the spread, right? So again, I'm gonna put these down here. Right. So our mean here is our center. So mu sub p hat lets us know we're working with the sampling distribution of p hat, working with proportions, is p, which in this case is 0.32, and sigma sub p hat is the square root of p times 1 minus p divided by n. So we're going to plug everything in here. And then we're going to simplify as far as we can go before it looks a little bit more difficult. So I'm going to simplify my numerator here. I'm going to divide by 1,000. And notice you get E. That means it's in scientific notation. So I'm going to leave this alone here and use this to kind of help me on StatCrunch. But I need to continue this. So I'm going to do second x squared to give me the square root, and then second negative will pull upon that answer. I'm going to close my parenthesis and press enter. So our standard deviation here is approximately 0.014751. Right? So we get our sampling distribution of p hat is approximately normal with mean 0.32 and standard deviation 0.014751. Ooh, so pretty lengthy process just to show that it's approximately normal and to calculate the mean and standard deviation. A little bit more tedious there. So now we want to continue on and kind of answer these last 3 questions here. So now it should be a little bit easier now that we've calculated our mean and standard deviation. So I'm going to move these down. So in a random sample of 1,000 drivers, so we haven't changed our sample size here. We want to know what's the probability that more than 30% have driven drowsy. So we're looking at the probability, the probability here that p hat is greater than 0.3. Right? So in StatCrunch here, we're going to use our mean as 0.32, and our standard deviation here is going to be, scroll up, the square root of 0.2176 divided by 1,000. So I'm using that in the simplest form here. And we're looking at the probability that x is going to be greater than or equal to 0.3, and that's what we're trying to find. So let's pull all of that over. So our mean here is 0.32. And then for our standard deviation here, we're going to type in SQRT for square root, parenthesis, and then what's underneath our square root. So 0.2176 divided by 1,000, and then close my parenthesis, and then x is greater than or equal to 0.3, and compute. So we're looking at about 0.9124 here. And then part C, we want to know, would it be unusual if in a random sample of 1,000, so same sample size here, 35% or more were driving drowsy in the last month? So same mean, same standard deviation. Just one extra component here. So we have the probability that p hat is greater than or equal to 0.35 is what we're looking for. So our mean is still 0.32, and our standard deviation is the square root of 0.2176 divided by 1,000, close parenthesis, and our StatCrunch statement here is going to be the probability that x is greater than or equal to 0.35. That's what we're looking for here. So I just need to change this one portion here to 0.35 and compute. And so we're getting 0.02, and careful here, 10. Right? And would that be unusual? So yes, since our probability here, right, is less than 0.05, right? So last question here. We want to know the minimum number of drivers that must be sampled to be sure that P is approximately normal. So the minimum number of drivers. So to be normal, we know there are two conditions. That's N is less than or equal to 0.05, capital N, and N times P times 1 minus P is greater than or equal to 10. So this one doesn't help us because we don't know capital N, right? So we're going to use this one. We do know what P is, right? So P is 0.32. So we're just going to solve this for N. Right? So we're going to do 0.32 times 1 minus 0.32. So this N times 0.2176 is greater than or equal to 10. And I'm going to divide both sides by 0.2176. So N's must be greater than or equal to 45.955888, etc., right? So we always round up with these, so we need sample 46 drivers here.